Well, as I'm sure you're probably already aware, especially for those of you that were planning on going to the SMRP conference, the 6th through, or I'm sorry, the 7th through 10th, 7th through 9th, whichever. In any case, it was canceled due to, a hurricane that's supposed to hit during the conference. And very, very, very important and good decision was made. What I thought I'd do, it was kind of a funny story. So we get to the airport, we get through security. I kind of felt that, wondering, because they warmed us up to it. They said at this time we're not expecting anything, and they've been warning about it for several days. So while we were in security, so our phones weren't on us, going in through the airport, the message came out, and basically that the conference was canceled. So we're getting messages and everything else as soon as I was getting ready. So I checked the app, and sure enough. So turns out other people were there from as well, so canceled the flight. United did a great job, by the way. Immediate cancellation, credit for the flight, even though I'd already checked in. Got our baggage for us. Fantastic. By the time I got home, I got on the phone, waited for the Rosen Center. I think it was a good hour on hold to cancel the reservation and everything else. Meantime, SMRP had gone ahead and taken care of all of that. And so really appreciate the Rosen Center. I got a hold of, because we had shipped some stuff ahead to our room, and they're shipping it back to us at their cost. I mean, really, really, really can't be upset about anything. So thank you, everyone. Kudos to SMRP's organizational group for the conference for doing a fantastic job yet again and taking care of this. We're looking forward to seeing what happens next. In the meantime, I was going to do a presentation and a product release on Tuesday. So I'm going to encourage other speakers to do basically what I'm doing. Now, mine was an innovation lab, so supposed to be a little bit commercial. Really, I do an innovation lab so that I can have a set spot that I select, and I always do a technical presentation. So the information you're going to get, I'm going to throw up our big product release, and that's it. It's going to be about 5 minutes. The rest of it is going to be what I've done my whole career, and we're talking about since the late 80s, in getting people engaged. As a matter of fact, my real work started in 1992 with the passing of the Energy Policy Act, and the company I worked for at the time, Dry Silker Electric, had given me the ability to go and participate in U.S. Department of Energy work. My father was involved a little bit. So we're going to talk about the journey that I took, including the research that I've done, the work I did at the university, and everything else. Well, I'm not going to talk about those specifically. I'm going to talk about the results of it. So I'll repeat that again in just a few minutes. For those who don't know me, because I'm loving that I'm going out to conferences this year. I disappeared from the scene for a little bit. I've been concentrating back on IEEE work, standards development, the work I'm doing in American Clean Power on wind, solar, and energy storage standards and best practices, and kind of helping rope that all together, dealing with some Hill-related, government-related stuff, things like that. So a lot of stuff going on. Moved that side of my career forward, and that meant that I was also working on product and getting in the field, because while I have a lab here, I'm in the lab, and we do a lot of research here. MotorDoc AI is my division for that, and we have a collaborative group of some universities and users, a little bit of government stuff, and so on, all related to industrial, commercial, military reliability, all the way to electrification through electric machines. So that's a quick bit. really my background or who I am. See if I can get this moving forward. Here we go. This is my background for those who don't know me. MotorDoc is a veteran-owned small business. I'm the sole owner of this company, and I served in the Navy in the 1980s. Actually, MotorDoc was my nickname from the captain of the aircraft carrier I was on. Right now, I'm the 2022 to 2025, and the possibility they may have me do a second term. We'll know in March for standards development for American Clean Power, which used to be American Wind Energy Association, or AWEA. I chaired the wind group, and now we've expanded it to cover solar and storage. So anytime we talk about standards for building, maintaining, doing all that stuff for wind power, whatever standards are written by IEC and IEEE, building codes, everything else has to go through our group to be revised and made sure that it all matches what we are required by law to meet. So that's very, very important. Past chair of SMRP 2018, past chair of the Chicago section of IEEE, which was 7,600 members at the time. That was 97 through 99. They had me serve a second year. I was managing the transition to digital communications for the chapter. IEEE Standards Committee since 1992. I am now, as of this year, so September was my first meeting. I'm the USA representative for CGRE, which stands for, I had to write this down, the Council International des Grands Réseaux Électriques, which stands for, and my French accent is horrible. I used to have one when I lived in Canada. International Council for Large Electric Systems. So this is the group that was founded in 1921, 90 member countries, and we basically do all of the research related to collaborative research, meaning a certain number of countries have to be involved in the development of any of the research, collaborative, and then published all through CGRE. I was appointed as the U.S. representative for Section A1, which is electric machineries or power generation and electromechanical energy conversion. That means I'm the one responsible now for doing the pre-work that IEC and IEEE end up using to develop standards for electric machinery, including insulation systems, wind, electric vehicles, etc. I also was assigned as the NEMA, one of the NEMA representatives for rail electrification, representing one of our clients, and the past research engineer for the University of Chicago Energy Resources Center, which was also 1997 through 99. All of my work, all of my research, my master's thesis was on motor management for energy and reliability improvement, and my doctoral dissertation was on a novel approach to energy waste stream process and reliability. I won a bunch of awards. I've done a bunch of things. I've got certifications from everywhere having to do with machine learning and AI and all the stuff we talk about now that's brand new that I was teaching in the 1990s at UIC. And then also served and founded the SMRP Government Relations Program along with staff. And then then that grew in 2015. And now I'm now on the ACP Government Relations team, focused on, things like workforce, smart grid, cybersecurity, and infrastructure for our power systems. So yeah, get it around a little bit. Because of some projects I was involved in, I went ahead and became a certified energy manager at the end of last year and got my certification measurement and verification professional certification at the beginning of this year. all related to a bunch of stuff. So that's my background. If you don't know who I am, I like playing with large electric motors and small ones, hence the Levad heart pump, which is about yay big. So that's it. Do a lot of stuff. Enjoy being in the field. So if you ever try to reach me, it's plane, trains, and automobiles. So let's get into our discussion. And I'm going to start out with this. Sell me this pen. It's AI powered, right? Everything has AI attached to it now. Hence, I had fun and I was like, you know what? Just out of spite, I'm going to call one of our divisions MotorDocAI.io. And it turns out it's one of our more profitable divisions from research. So all the work we do, half of what we do gets put back into research. And this was kind of the joke. So, if I take something old, shine it up a little bit, and put AI and cloud to it, then, somehow that makes it a wonderful thing. But there's more. We start talking about digitalization of factories, everybody's using the word, everybody's going forward with it, everybody's doing all this stuff, everybody's talking about energy efficiency, everybody's talking about emissions reduction. And we had already figured that out in the 1990s, the best approaches. So we're going to talk about that a little bit and where those resources are. They're free. You paid for them if you're in the U.S. Through your taxes. Canada, same thing. So all of that stuff is there. I'm going to provide and show you those resources really quick as we go through examples of how things like belt alignment, precision maintenance, stuff like that ties directly to your corporation's energy and even some of those new emissions goals. Well, not really new, but the ones that have been popular over the past few years. Getting into that, I had a challenge, or a challenge was made to me a little while ago because of some discussions that were going on with AI and generative AI and stuff like that. And I said, it's a great assistant. I can do a lot of things with it. I can cut down time on stuff and everything else, but not the way you think. I do not see AI or machine learning even replacing jobs. I don't see it. It can't happen because, regardless of what all the marketing and sales folks are telling you at all of our conferences and online and everything else, I'm sorry, it's very easy to pick out this generative stuff, even the new faked ones. So average intelligence, half people are under, regardless, it becomes relatively straightforward to pick that stuff out because of how it presents itself. But it makes a great assistant, a great way to enhance what you're doing. So in the programming side of what we do, the challenge came down to this. Can you actually write a program from scratch with generative AI? And we did it. So I spent a while, and I'll attach a video on this. It'll be in the newsletter as well. I did that yesterday for my podcast or my vlog. This little guy came available, and this little guy here allows me to take in electrical data, current signature data, and also vibration data. You'll notice I have one has a little thing on it. That's the vibration side for ICP type data, and then this one here, and it converts it over to something that I can manage that we did in a software program called Python, which makes it really kind of nice. Nobody has to buy licenses for anything. So we did that, and I'm just going to say I'll put a link to that video. Actually, I'll show you real quick. So that allows me to do some stuff. So let's go ahead, the Empower. Okay. Now this is my commercial stuff. So with the Empower, I can take any type of current clamp that puts out millivolts per amp. I connect it to the device here and plug it into a USB port, USB or USB-C port, and connect it on. And in 2 minutes, I can collect data using the new analysis section of this. That'll automatically do all your settings and everything else, right? So I can set up specific stuff for a motor. I can set up alert bands. This commercial part's going on more than the 5 to 10 minutes I said that we were going to do at the conference, but I got you trapped here. So I'm going to just spend a couple of minutes just showing you an example real quick. I won't do a full tour. I'll just say the analysis is performed on this part. I can even do kilowatt losses, some additional stuff. I just put in motor nameplate stuff and everything else, and the base settings, all built around the calibration of that device. So this software is what we built that works with that hardware. The hardware is included in our release product called the Empower, or the Electric Motor Performance Optimization, Waveform Evaluation and Recognition, which adds to what we do with the Empath systems from Framatome. Okay, so let's take a look. We're going to open up, and I'm going to, for demonstrations, just so you can see what's going on in the background, let's take a look at a small electric motor. You'll notice it's a sound file, and these are JSON. That means we don't have a huge leap for when we put this online. Yeah. So part of what we're doing with this is this will release, the full version ships on November 1st. I had originally said we would have the beta out, but we wrote this whole thing using support systems through, OpenAI, Microsoft, and then GitHub, and a few other AI systems that helped us take a look at the structure of the software. The algorithms are ours. We didn't allow AI to touch that because it hallucinates stuff. And there's some tweaking still to do in here this week. It was going to be next week, but now it's this week. And these will be ready to ship then. It's going to be well under 10,000. As a matter of fact, I'm going to have a steep discount between November 1st and December 31st. There are no annual fees, no anything. You buy it, you own it. As a matter of fact, you can put the data wherever you want. The cool thing is, once I get the data up and I'm able to look at all this stuff, and I'll put the link to the demo video. Wait till this expands here. Navigation stuff and everything else, I can zoom all the way into each defect's kilowatt rating. And then I can even have it calculate that and what the emissions rates are. This table here will list each opportunity and the energy associated with it, and of course the emissions associated with it. You'll notice I've got a nameplate in here now. It's a small motor. Let's do no coupling, so that it's not going to try to calculate out everything else, because the driven equipment, it's going to, if I say belt application with a pump or fan, it's going to adjust the speed, including slip going into that, so I can look at the bearings of that from wherever I take current. So I don't have to reach in and put voltage clips on and stuff like that. We've come up with the ways, after decades of work, we've come up with how to get around some of that. But if I want even better accuracy, then I go with the Empath instrument. So we're here now, got the data open. This, by the way, is 2 minutes, gives me accuracy down to 0.01 hertz across the entire spectrum. The actual spectrum goes out to 20k kilohertz, but most everything that people will be looking at is within 5 kilohertz. Auto analyze, it's going to run the analytics, and then it's going to show me all of the cursors for all of it. So if I'm learning how current signature and electrical signature works for low cost, I can literally run through everything. It's going to identify it. It's going to throw those up there. I can go along with the green book, which ships with it. The green book, and it will tell me how it's calculated, and I will see where those calculations are, because everything in the software comes from this. So here we go. It's almost done. Now it's just doing the plots. Now you notice these humps here. That's an inverter. So 2 kilohertz setting on the inverter. This down here is the line frequency. That'll be 50 kilohertz for this one. 50.02 actually. And it's going to calculate the running speed for me. Now, what's nice is if I have a strobe or something and I disagree with the running speed, I can type in the running speed and rerun the analysis, and I'll base everything on the speed I enter. So if I don't agree with it, it's going to go down to 2 significant digits, 0.0 whatever, in order to get me there. So it's at 1500.49 because it's over this. It has no coupling or anything else. All of my peaks associated with bearings, dynamic and static eccentricity, pole pass frequency, findings. So it's also showing up here. Pole pass frequency is a false positive because it's blended right in. I'm basically running almost synchronous. I come over here. It's going to put all those cursors here plus identify line frequency. And I can even have it analyze that to tell me what my opportunities are in everything, including emissions reduction and everything else over the course of a year. That's it. So that, starting the ones that ship November 1st through the end of the year, those will run at, well, let's just say well under 10K. Just need to contact us for a quote. So we got that out of the way. Let's go through this. Now, this is going to go for about 45 minutes. I did this presentation at AIST, and some of the research that you're going to see on how to convert vibration data to energy data is referred to in here. The calculators are free for you to use. You'll find one online at MotorDoc AI. If you reach out to me with an email, I will actually send you a link to it to do what I will show you in the end. So overview of the concept, starting with ESA data. Then we're going to get into how to use my motion amplification and my vibration data to calculate things. There are a ton of other stuff. I'm going to show you exactly where to get those resources. Okay, so let's talk about tying our electrical signature analysis system, or actually our reliability and maintenance program, to corporate and emission goals. Why is this important? Well, you know what? I keep hearing this. We need to talk to the C-level. They need to understand. They need to do this. Oh, we can connect safety with that. And yes, there is a very definite correlation between safety and our maintenance reliability program. Now, I do a little bit of sales. Of course, I have to. I own a business, right? So I just have a hard time going into the C-suite or senior management and asking a simple pain point question called, how many people did you kill last year? We can reduce that number. I'm sorry, it just does not. How many people did you maim last year? Well, we can reduce that number. I'm sorry, I would rather remain a correlation where I can say we're going to improve your safety as part of it, but I have to be able to show a tangible number. Okay, so if I go in and I say, oh, you killed 2 people, well, you only kill a half a person next year. That is ridiculous. You can't do that. But one of the things that shows up on a P&L sheet, on a P&L, is energy cost. Yeah. And since the 1990s, when I've gone into corporations and I've implemented programs, matter of fact, the previous iteration of MotorDoc, where we were called Success by Design at the time, that was prior to the 2009, mix-up. My primary clients were General Motors corporate on the Quality Network Plan Maintenance Program, U.S. Steel, Amtrak, and a couple of others where we had a team that worked on programs there. I've won awards over this because I could tie the programs we were putting together directly to the energy costs. Matter of fact, one of the programs launched by DOE was directly because of my contacting associates at DOE that I worked with in the 1990s. Some of those programs, Motor Challenge, Air Challenge, all that other stuff, I was one of the authors of some of the manuals and worked with a team of over 75 people on the electric machine side, including VFDs and some of the other folks, in developing the tools and technologies and software and testing it and implementing it, all related to that. As a matter of fact, funded through Altest Pro and a couple other companies. Proof Technique, I believe, was one of them. Yes, Greg Lee. So put those together and tied that in to the actual Motor Challenge software to focus on energy and reliability. Matter of fact, what we found in the 1990s, after the Energy Policy Act of 92, was you can replace motors all day long. You can replace HVAC systems all day long. The energy engineers love that stuff. It's really simple for them. They throw together a calculation. They throw numbers into a model and yay! But what we were pushing that entire time and what we found is the maintenance, just actually performing the maintenance you're supposed to do, has a significant impact on your costs, your energy costs. That includes steam, air, electricity, any fuel source that comes in. Okay. As a matter of, when they talked about it going from a reactive-based program to a planned program, just this small little tiny bit of a program can reduce your cost by 14% or more. And we've seen this in practice at the National Institutes of Health. They had taken over in their CUP. They had gone in and put a program together in which they took care of the chiller systems and everything else. That was through AMS. They took care of the bricking in the boilers. They took care of just performing standard maintenance, alignment, greasing, all this stuff. And we all had input into it. And that decreased their energy costs by more than 50%. Enough so that money could then be put into other energy conservation measures. That's direct, tax dollars. And it was really, really good. It happened fast. And I've seen it in a plant, a small plant, a really small plant, actually, a small paperboard plant in Aurora in 1995, just on the motor systems. We took and we improved the maintenance programs there. We said we did it as an ESCO. We would come in and maintain it. And we would get a percentage of those savings, and another portion of that percentage would go into their own maintenance program to continuously improve it. Everybody was doing really well until a third party came in, bought the place, and figured they could save money by killing the maintenance program. But safety also improved there. We've seen it occur, and it's phenomenal, and it's measurable values, and that's what we're going to talk about. We are going to talk about, for today, to keep this limited, we are going to talk about the electrical system. So from incoming power to driven equipment, we will talk first about electrical signature, where we take our data on the output of the controls going to that motor. That control could be a VFD, cross-line starter, whatever. Okay? And everybody's ESA devices, well, the main ESA devices, Empath and now the Empower, PDMA and Baker primarily, and then Altest, of course, which is the Empath. They all will show you good measurements. Most of the other stuff, we'll see. But they'll break it down mostly by component. Now, what is electrical signature analysis? And this is part of the difference between the Empower and the Empath, right? So the Empath is a pure electrical signature analyzer, 3 phases of voltage, 3 phases of current. By definition, it's a power analyzer. So I'm looking at voltages upstream, current is downstream, and then I've got all the power quality in between, and motor current signature analysis, a small portion of that looks at things like the condition of the air gap and the rotor and so on and so on and so on. Matter of fact, for years, people thought that current signature and ESA was basically a rotor tool, and that was a waste of time and energy. Heck, even NAVC gave me the papers recently that they had produced back in the early 1990s, was already looking at pump systems, belt condition, and stuff like that on ships. So the technology is not new. It's been around since the 1980s. I think the scary thing is everybody goes, oh, electricity, oh my gosh. Well, in reality, what it is vibration, where I use the magnetic field of the electric machine as a transducer, and I can take different types of measurements. Current signature analysis, which is the Empower, I just need a single phase. Now, I won't detect the loose connection stuff that I will with ESA, but all the mechanical conditions, electrical conditions of the motor, just like I would with vibration, including things like softfoot, that all shows up, condition of the coupling, and all the components in the driven equipment. In a wind turbine, I do the transformer, generator, coupling, 3 stages of gearbox, a planetary gear set, the 2 main bearings, and even the condition of the blades. I mean, through a reading that takes 1 minute with the empath and takes 2 minutes with the Empower. Okay, so that's part of it. But we see this all the time. I mean, the other week I went out and the guy said, well, this, I need you for 3 days because we're doing this many machines and it takes this many days for the vibration guys to do it. I get there, we were done in a half a day. So it's a much faster thing. I go into a nice air-conditioned space. I'm not crawling all over machines. I take data from the panel. Now, don't get me wrong. You noticed that there's a vibration connection on that device. And there is also the ability to add vibration to the empath. I am a strong believer in vibration as well. Often when I go in the field, though, most people are expecting me to do ESA. I do all of it. So or my team does all of it. So we believe in all of the technologies. I'll go out and knock the socks off of people that I'm detecting problems that they may or may not have hit with their vibration. Usually the reason why is incorrectly placed vibration transducers and inexperienced people, or they're using this AI crap. Did I say that out loud? So energy consumption, that's one of the benefits of using ESA. Now, in Empower, we estimate the values based upon the expected voltage. But because I have voltage and current in 3 phases in both, I can get pretty accurate down to the efficiency of the machine I'm testing. Okay, so here's some data. It's a belted application. I need to know belt information. It gives me driven load. It gives me certain other things so I can identify the signatures and the slip. So I have all this information. It's a 300 horsepower motor in this case. Let's take a look as we go through. So across the line. Now, here's what happens. If I go in and I do an inventory evaluation, there's 2 ways of getting that data. I'm going to show you that after I explain this. I'm going to show you the greenhouse gas equivalency calculator. And the fun part is I'm doing this online, so I don't have that 1 hour time slot. So I can talk a little bit more instead of vagaries. I'm going to give you exact stuff. Isn't that exciting? I'm a little hyped up because I was expecting to be sitting on an aircraft for 3 hours staring at the back of somebody's head in the chair in front of me. So national averages, we're going to use that. So a national average for inventorying my greenhouse gas emissions is right now 0.17 metric tons of CO2 per megawatt hour. Okay, so metric ton is 2,240 pounds of CO2. Okay, so whenever we do this, we talk in terms of metric tons. Normally, we also produce it in kilograms because most of the rest of the world, that's what they talk in, so most of that work is there. But we can also produce it in pounds. Okay, so inventorying, which takes the entire energy production, including the base, we use that. Now, if I go in and I say, okay, I've made some improvement. Okay, so the first one comes from something called EGRID, E-G-R-I-D, which is Department of Energy and EPA. For energy improvements, that is actually called AVERT, A-V-E-R-T. Now, that is slightly different because they look at the energy mix differently for improvements. It's a method of removing the base. So this is where we have the greater emissions portion instead of the variable loads such as wind, solar, etc. So 0.699 metric tons per megawatt hour of CO2. So basically, there's a slight difference there. So I get an advantage by making improvements. That's a simple calculation. So if I go in, I can make that statement. Okay, so let's say on 0.746 times horsepower to get kilowatts and vice versa. So say I have a machine operating 6,000 hours per year, $10 per kilowatt demand. That's the total, the largest kilowatts for whatever period, for whatever. And 10 cents per kilowatt hour, because I hate math and using tens is far easier. And I have that machine we just looked at. So incoming power right there at the connection. This is the shaft power. That incoming power, 193.5 kilowatts, times $10 times 12 months, that is $23,000 in demand. If I look at that in usage, okay, 193.5 times 10 cents per kilowatt hour times 6,000 hours. So this is the maximum, that's the peak load, 116,000. So close to $140,000 per year to run that electric machine, that 300 horsepower, at that particular load. Now, if I have varying loads, I can put that in there, etc. But for our purposes, I'm going to keep it simple. So if I take a look at that, and I say, okay, we're going to take a look at this, and we're going to convert it over to megawatts. That comes out to 1,161 megawatt hours to operate that electric motor per year, times 0.417 tons of CO2, metric tons. That is 484 metric tons CO2 per year to operate that machine. I don't give this number to management. What I'm going to do is any improvements I make will be significant as a result. You figure the average improvements are going to be 3 to 5% on a properly operating motor. That includes greasing, alignment, belts. That's a whole other story. Belt alignment, big deal. As a matter of fact, go see the guys who make the bat. There, I thought I'd throw something in for one of the vendors that were supposed to be there. So let's take a look at this. This is the EPA Greenhouse Gas Equivalencies Calculator, okay, and it's the EPA.gov. You can look it up as the greenhouse gas equivalencies, okay, and you can see it covers all of the different sources. So let's say we are going to make a correction. We say kilowatt hours avoided, and say we reduce the kilowatts in the plant by 1,000 kilowatts, and I convert the data. It's going to do a couple things. First off, there's that 0.699 metric tons. I can change it to pounds if I want, or kilograms. So it says we're going to do that. We're going to be taking that value, so that is all of this stuff here. So the equivalence of all of this, so it comes down to, 0.699 metric tons, because I put in exactly 1,000. Let's say it's 1,200. Let's get a different number in there. So I convert that data, and it's going to give me 0.838 metric tons. Okay, so that's not a large number. That's in kilowatt hours, not megawatt hours. So that's 1.2 megawatt hours. That is greasing a bearing. Seriously. So you can reduce almost a metric ton just by greasing a bearing. Now, if you've got one motor in a plant, I can see where you say, well, maybe it's not worth it. But if I'm putting in, I saw one machine that was an older one, and they had just a dry bearing. It was 5 kilowatts. Now, it was a big motor. It was several thousand horsepower. And when we got done, it was massive improvements. But what they do on here in the calculator is they show all the equivalencies. Okay, so, well, they used to show more. But, so that's kind of it. If I come in here and I say, okay, it's let's say a 250 kilowatt machine, I can convert that over, and it's going to tell me, Oh, that's kilowatt hours. I'm sorry. 250, let's say 1,000. Just for fun, say 1,000 hours. That's 104 metric tons operating. So there you go, and there's the equivalencies down here. This used to be a much longer list, so they just changed this recently. But that's there. You've got access to it all the time. Okay, so we paid for it in taxes, right? Out of here. Okay, so let's get back to this. Let's consider a facility, a 3 megawatt facility. This is actually a real facility. So a 3 megawatt facility operates 24/7. That's 3 megawatts at 8,760 hours, which is the number of hours in a year. That's 26,280 megawatt hours. I convert that over as kilowatt hours, and I can get an idea of cost, okay? Now, there's a lot of other stuff that I have to put in, such as riders and everything else, but I'm just going off of the exact usage and demand costs. So if I've got stacks of them over here because we're doing a study for a company, but if I take a utility bill and I go through it, there's a lot more than this. So, but I want to concentrate on this. So this is, basically a $3 million a year if I use those same numbers as before, and about 11,000 metric tons of CO2 per year. And that might be, they might also present that as 11 MMTC. So if you see MM, that means million metric tons. Okay, so if I go in and I take a look at this machine, and this is a belted application, I see a belt signature. It's no belt flapping, but this is a belt signature, so there's something going on there. And I look at the air gap related stuff, and by the way, there's some turbulence involved. Now, I can actually do some stuff if I just have torque. Okay, torque is, well, let's put it this way. I need to know the exact frequency that I'm considering. Okay, so if it's 660 RPM, that's there. If it's a lower RPM, like this is 90 RPM down here, I calculate it from there. So 660 RPM, 5 foot-pounds divided by 52 gives me horsepower. I convert that over by multiplying that by 0.746. That gives me 0.47 kilowatts. That's the loss because of this belt frequency right here. Okay, so that belt frequency right there. And then the turbulence, which is all this stuff here. So if this was on a pump, this would be cavitation. If it's a fan, it would be turbulence. That peak there I take and I would multiply that by the RPM associated with, or the frequency, divided by 52, which gives me this. I add those both together, I'm just over 1 kilowatt. And I take and I can split those out, and my cost associated with the belt, which over tension. So I didn't look at things like the static eccentricity that goes with it. That would increase this cost a little bit, by the way. So $338 and $439. So if I take care of that turbulence through whatever measure I need to, there's a cost associated with it from an energy perspective, let alone wear and tear on my fan or pump impeller. Okay? This way, I can do the exact same thing here off of the, this is empath, off of each of the peaks. This is in kilowatts. So 0.46 means 460 watts, or 0.46 kilowatts, whatever it is. So when I take a look at this, and I say just for those two conditions, I add those both together, and I multiply that by the 0.699. That is, if I correct the belt, and I do some adjustment to reduce that turbulence, I'll save 4.5 tons of CO2 per year. Just that one application. Now, this is another belted application. It's a little worse condition. My header disappeared. Sorry, my phone's going nuts in the background. I think people are realizing the SMRP is not going on. So I take a look at misalignment in this case. This would be a belted misalignment. This is where the bat comes in. Or any type of precision alignment. You also want to talk to Hendrix because they're into the precision stuff and they do the precision training. Now, it's 2 vendors from the conference that I've mentioned so far. I'm going to try to do that a little bit more. But anyways, so I take a look at this belted application. Here's my information associated with a little bit of belt stretch going on there. But there's ways of calculating that. See the green book. And I come up with this. So 109.1 kilowatts coming in, 100 and whatever going out. Those, everything in between are the losses inside the machine. If I exceed the losses in the machine when I'm coming up with a calculation, because there's some folks out there that are doing that crap, it can't be real. So if I'm being told a 1 horsepower motor, which is 0.746 horsepower, is somehow saving 20,000 or using 20,000 kilowatt hours worth of energy, 0.746, that means fully loaded, times 8,760, nowhere comes near 20,000 kilowatt hours. So if I had somebody try to tell me at a conference, and this has been repeated a couple of times, oh yeah, this little 1 horsepower motor, it's got a noisy bearing, it's doing 20,000 kilowatt hours a year, run away. So in this particular case, this belt is slipping by about 11.5%. So when I take a look at it, I can take a look at the belt slip in this case, and that comes out to about $3,300 in demand, 4.6 kilowatts, misalignment, 3.1 kilowatts, so that's 22. So we're talking about $5,500 in energy costs per year based upon a misaligned and slipping belt. And I love belted applications because I get numbers like this all the time. That comes out to 32.3 tons of CO2 per year. Now imagine reporting that to your management. Okay, I get it. I get pushback all the time. I don't believe in this or that. I don't care. I'm climate agnostic when it comes to this stuff. I'm not pushing an agenda. My customers care. So I'm going to produce numbers to my customers that make sense to them, that they can apply, that are real. Okay, so if they have a greenhouse gas emission reduction goal, I can tie my testing directly to that goal. That's why when I go in and I talk to management, plant managers and everything else, when I'm sitting there and I'm looking at data and I say, you know what, it's costing you this much in energy and by the way, this much in emissions, next thing you know, I'm talking to the plant manager. How many technicians can say that? That's right. If I say, oh, I'm going to avoid these costs and avoid this and avoid that, those aren't measurable values because it doesn't exist. It hasn't happened. If I can say I'm going to reduce this much and then show a before and after, sorry guys, I can measure that and I can report it and I can take credit for it. I always recommend you start working with your energy managers because it's phenomenal. So let's take a look at a gearbox. So I have a gearbox, slight problem in there, a little bit of excessive wear. So I take a look at all the frequencies associated with it. Comes out to 4.3 kilowatts in loss. I can apply the cost to that, of course, and if this operating 8,000 hours, 24 tons of CO2 per year. Okay, and then I can even, if I don't have that, if I'm going in there and all I have is a power analyzer and I can do kilowatts before and after, take your measurement before. Okay, I don't care if it's a fluke or whatever else. You take your power analyzer, you get the data, and then after, you take the measurement in the exact same load or close as you can. So in this case, 175 to 163. Now what we did in this case is, this is a real application. We had 10 D belts, huge shiv. They were breaking shafts every few months. There was a big going on about fixing that. So we went back and I said, here's the projected energy we can save by going to 2 V belts, slightly larger shivs, and that reduced the overhanging load, the overhung load on the shaft, less chance of breaking the shaft. Now, I had done this also at a plant at General Motors. The savings were huge. measured and everything. So I knew this was going to happen. So we did that switch. 175 to 163, that's 12 kilowatts. So not minor. So when I take a look at that, 12.5 kilowatts, it's $9,000 in energy. By the way, that meant almost immediate payback on everything, right? And 52.4 tons of CO2. 52.4 tons is what sold the project. When I was talking to the plant manager, I said, for each of these 14 systems, we can reduce your emissions for your plant by 50 tons each. And he had emissions goals. What's in it for him? Reducing the emissions goals, or hitting the emissions goals so he could get his bonus. Found what he needed, and I was able to produce a report that said this is what you reduced. That was measurable, so nobody could say he pencil whipped it. So let's take a look at a 600 horsepower pump motor on an inverter. I've used this one a few times, so if you've seen me before, you might have seen this example. So it had a couple of problems. It had a bearing issue. It had soft foot. So we're going to take a look at that. It had an impeller issue as well. So we noted, and here they are. So when I'm looking at the kilowatt analysis in the empath, and the Empower does the same thing, I can take a look and say it's an estimated value in the Empower, so it's going to be slightly lower. It's going to be lower. So I take this and I say, okay, quarter, so it's just a little bit of friction increase. Okay? Barely perceptible with vibration and some other technologies. I'm just going to say that. So just barely perceptible, right? So we're seeing it already here. Pump blade, which, by the way, was a little ding in the pump blade. They dropped it on installation. That's the damage. I convert that over. That's 2.9 kilowatts, just from a little ding in the blade itself. Not the outside or inside, but the blade. And I add all these together. That comes out to 5.5 kilowatts. Okay? So with using that 10 cents and 10 cents per kilowatt, or $10 per kilowatt, which, by the way, is really cheap these days, I guess, $5,500 in losses per year. Okay, and 33.6 tons of CO2. So as you can see, if I start adding these together, every single day I could be making strides. And believe me, there is no lack of opportunity. Steam, same thing. I just, put stuff up there. So in any case, here's that conversion thing. If you have a hard time finding it, I've got a direct link to it on motordocai.io. You go in the lower right. You can actually enter your data there. It's just a link directly to it. For those that are in sales and marketing that are watching this, you can do the same thing. You go, they have an app that you can put on your website, and it'll open up the whole thing. Your customer can put that data in there, and it'll be a direct link. So if I take a look at this total, just those opportunities I just mentioned, okay, you're talking about, if this was in that one facility, about $25,000 per year at least. I always say these are conservative. It's going to be over this by a lot. 147 tons of CO2, metric tons, and kilowatt hours avoided. I can put that right in here, and it's going to calculate all of this and do the verification for me, and then I can present this to management. Okay, so here's what it came up with, 147 metric tons. Basically, 147 metric tons. So everything I calculated, I just did it manually. There's how it produced it, how it produced this. Okay, and let's talk about this. Precision alignment, precision maintenance, proper lubrication. You hear these people running around saying, I've got a lubricant that can reduce your energy. And reduce the energy. If anybody says that energy improvement, a failing bearing, a bearing that's about to start dragging and causing you a lot of problems, can be no more than 3% of the unloaded losses of the machine. So that means like a 100 kilowatt machine that's 96% efficient. That's basically four kilowatts are my losses. 3% of that is going to be bearings. Okay, worst case, if it's just about to fail and you got a lot of drag on it, you might get to 3 kilowatts. But you're not going to get more than the losses of the machine, right? So more the potential losses of the machine. That was a study done in the 1990s. Precision alignment, misalignment, and soft foot have a huge energy impact. Okay? Proper lubrication has an impact. Cleaning the motor has an impact. Balancing the motor has an impact. Not huge, it's there. Okay? Those losses, all of these losses, when we're measuring the kilowatt value or the watt value, in a lot of cases it's watts, right? But it adds up across 6,000 or 8,000 hours a year. Those losses are going into heat, sound, and vibration, okay, which is important for the next part. Now, there are tools that we have access to that are free. These are Department of Energy tools. Now, what they did is they took all the tools we worked on, Compressed Air Master, Motor Master, all of these things, and they made it an open source software. Okay, you can even ask them permission. Can I use this in my commercial systems? Yes, you can. Okay, so bound it all up in Measure, and they added a bunch of stuff. This is from Oak Ridge National Labs, by the way, the home of the empath system. So this is where I can go in and not only keep track of the improvements that I'm making, but I can also do the simulations beforehand. So I can go, if I make this improvement, if I do this, what's the scenario? What are my potential savings ahead of actually doing it, right? So if somebody says, well, what's that going to do for me? Go to Measure. The training is online. It's in YouTube. It's on the Department of Energy website. Okay. The other resource, eGrid, that's the energy profiler. And then, of course, we talked about this one. I showed you this. So now how about your vibration data? Now, this challenge had come up when I mentioned the 1 horsepower motor and some companies that are running around using this for measuring energy data, and I take it very seriously. So if I've got some schlock running around telling people fake numbers that aren't actually able to be tied to anything, just to sell an instrument or sell a program, those punks, because, this is SMRP, so I won't speak Navy. It really pisses me off. We'll just put it that way, because this is a real opportunity for us to be communicating with the C-suite. And you've got marketing con artists running around and sales con artists running around trying to sell you crap with made-up energy numbers that will harm any chance of getting this done. So we went ahead and we did some research. Conservative values, but this is the calculator. I'm going to show you this in action in a little bit because I can do things with this. I can, I made the calculator up. It's a little executable. It's in Python. You can run it on any Windows machine. You can even run it off a USB. I don't care. If you want it, email me. I'll send it to you for free. Okay? So I just want to know who has it. That's it. There's no licensing or anything else. You click on the executable, it launches. You don't have to install Python on your system, nothing. It's all self-contained. Okay, so I come in and I say it's a 1788 RPM machine. The weight is really, really important in order to do this because this has to do with kinetic energy. Okay, we did kinetic energy and we came up with a curve. If you want the paper on how we did it, email me as well. And my email is there it is, info@motordoc.com. And then I put in my numbers. I can put it in inches per second or millimeters per second. It all is going to convert over to meters per second. But let's just say I'm doing inches per second. It's just going to add these up. So if I put a spot there and a spot there, that's fine too. I don't have to do, both. Then the operating hours per year, and then the tons of CO2. I can get that from my area. The avert will bring it all the way down to your county. And then there's, if you're outside the United States, the EIA, Energy Information Administration, EIA.gov, has the equivalent for most countries. Okay, so I put this all in. I calculate. It gives me the amount of energy opportunity, the energy losses associated with it, the consumption total, the metric tons of CO2 associated with that, and the energy cost associated with that particular frequency. Okay, so I have to pick this out by frequency. This is not overall. So if I have a one-time RPM, 0.2. So let's say I have misalignment and I want to tighten that alignment up to get my values down to 0.04 inches per second. So if I put in all the same numbers here, that drops me down from 3.16 watts to 126 kilowatts to 126 watts. Big difference. There's always going to be some losses. Nothing's perfect, right? Actually, if you get perfect, you have a different problem. You get resonance. But then it will show me the difference in cost associated with that defect. And that I can use to show my return on investment for, say, a proper balancing job or proper alignment. And I can make a statement that, we're going to reduce 3 metric tons of CO2. We're going to reduce 26,000 kilowatt hours. So when I take, energy, energy. So that should be kilowatts. My bad, kilowatts. That converts to this and $2,600. So a couple extra minutes making sure that my balance is really good, making sure the alignment's good, or justifying cleaning a fan, by the way. So the unbalance goes up because I got a dirty fan. What's the impact if I clean it? Well, here's your measurement. Okay. Now, this is the second to last slide. Just an example. Now, if I really, really, really want to do well, I can go ahead and from incoming power by keeping track of things. So in this case, this is a place without production. It's pretty flat. I have dry bulb temperatures and I have energy costs. So this is kilowatt hours consumption by hour or by day. I'm sorry. 2023. Yep, by day. And this is the max temperature, dry bulb temperature per day. I can keep track of that. This is when an energy conservation measure was put in place. And so you can see it's following this curve here, but it's doing this at a lower level. If I'm monitoring incoming power, which is what we do with the ECMS E1, we've got a lot of them in the field measuring what's going on. So we get details that we can take in on our cloud system. We do it on AWS. We keep track of all of that in dashboards, and we can actually tell people, your energy, your work is generating this much, or we're seeing this going on. And you can tie everything right back as a result to the energy bill. So with that, and then, there's that. And then I use special tools. Don't do this in ChatGPT, okay? So I can get help with it. It'll help me write the program, but I bring it down. I do my own. I don't use anybody else's calculating system because that introduces their bias. I use a raw system built in Python that we developed. I prefer my own biases, basically. And we bring those in because I got everybody trying to sell me on this stuff, and I take a look at their stuff, and it's got their biases in it. So it's like, oh yeah, well, we just calculate what it might be with LED lighting, and we just did the site. As a matter of fact, it's this site. They put in LED lighting and increased their energy cost by 1.3%. In the meantime, all of the models had shown that they had a huge decrease in energy consumption that was not matching their bills or incoming power. So we showed that it was a slight increase. We applied a technology to get rid of all the harmonics that had caused their increase, and that reduced their cost to what they were expecting to see. Okay, so anyway, so in this case, say we take a look here when we applied this measure. A standard linear regression didn't do what I was looking for, so I went with a random forest regression, and that meant that they had a 4.63% energy improvement through their lighting thing after applying the other technology to clean up the power, and the result was 46 metric tons CO2 per year reduction. So just from getting an energy improvement, and their energy cost dropped. How do you beat that? Okay, and the cost to implement it was abysmally low. I mean, there was rebates on everything to top it off. So with that, if you have any questions, please email me, info@motordoc.com. Let's go back to, I think I have it on the beginning slide. I really do. I don't mind questions at all. There we go. Will it do it? I guess not. So let's go all the way back to the beginning. Just so you get it. Because some people will spell it wrong and wonder why they don't get a response from me. Okay, so info@motordoc.com. It comes to me and some of my people. Ask away. If you wanted a link to anything, if you wanted a copy of the calculator, which is, right here. Which is right here. Just ask. And like I said, I can open up multiple instances of this and put side by side. It's really simple. Put side by side opportunities, and even copy and paste the results into something if I want, or take a screenshot. So with that, I did go over a little bit, but sorry, I was doing my product release in the beginning. Good news is I didn't do this on Tuesday because I had 11 a.m. to noon, and we would have been about 10 minutes into lunch. Sorry. No, actually, I would have cut everything down. I've got this time down to under an hour now. So always consider that this energy and emission approach is a potential KPI that will get your maintenance program attention, in that you are actually speaking then the language of the C-suite. And that language involves how do they reduce, not just, if I go in and I say OEE and all this stuff, people keep pushing on me that, they all know what OEE and all this other stuff is. And I'm sorry, I get together with too many boards, and I'm dealing with too many senior people in organizations, from Union Pacific to General Motors to all these other companies. And when I'm talking to the senior management people and I use the words OEE, they kind of get a blank look and they shake their head. Yeah, okay, yeah. Oh, I know what it is. No, they don't. They're not taught this stuff. Okay, they are taught the P&L. That's what they use. They look outwards. If you're telling them that they have to look inwards at what you're doing for a job, they're not looking outwards, doing what's necessary to move the company forward, whether it's taking care of shareholders or selling widgets or whatever else. Or if you say, they're now a data company, and you're talking about, a large company that sells food, they're not a data company. They are a food company. They might use data to make some decisions, but, sorry, it doesn't work like that. When I go in and I say, here's the energy, here's the emissions that are going to be reduced, I get a response. I get the responses I want, and I get invited back. Okay, so with that, I'll leave that to you. If you again, any questions at all, info@motordoc.com. I will gladly answer them, especially this upcoming week. I'm going to be sitting down with our programming guys, getting rid of the last couple of things that the version we release on November 1st will be a full version of the Empower. Now, I forgot to mention, but on the Empower, each unit sold $75 of each of those of each sale, regardless of discounts or what we do, is going to go to a veteran and first responder organization. We're working out with a couple of them which ones they'll be. We're going to do one a year, and that money is going to be donated directly. So as a veteran-owned company, it's a way I want to give back. So with that, have a great week. Sorry I couldn't see you at SMRP. Really wish we were there. Was looking forward to having a bit of a party with everybody. But they did the right thing. Thank you very much.